Hi, it's Bruce. Welcome to my Rocky Mountain lab. And today we're looking at yet another ESI DV411. It is well, technically, I think a 5 decade divider. We've got four active dials. The last dial is a potentiometer and is capable of 2 digits, but you have to be very careful. We'll talk more about that in a bit. It's a Kelvin Varley um, voltage divider based on Lord Kelvin's design. And it's hand-wired resistors using special thermal alloy material and really great switches. Um, got a heavy-duty cast base, a pivoting panel, I guess you'd call it. I don't know. You can raise and lower the angle of the controls. It's in beautiful condition. A little ding here and there. I mean, it's for something that's every bit of 50 to 70 years old. It's in wonderful shape. I did give it a coat of paint after I cleaned it. I took the housing and all the electrical connections off. I cleaned all of the switches. Put a couple of new. I had to actually tap out a couple of these binding post ends because they were missing. But I've got two binding post ends on there that work well. The whole thing was then put back together after it was spray painted, and then we tested the operation of the whole thing, which is on video, and you'll be able to see the results. Not quite sure what these things ran in their day, but they weren't cheap. Would have been actually quite expensive, I would imagine. Be interesting if somebody knows. Has a catalog price sheet maybe. But we're gonna give this thing a test of its linearity. It's rated at linearity of 0.005%. Has an input resistance of 100,000 ohms, and it's plus or minus 5% of that 100,000, 0.05, plus or minus 0.05% of that 100,000 ohm input. It'll handle a voltage up to 750 volts on the input and divide it down on the output. It is not meant, being a Kelvin Varley voltage divider, it is not meant as a power source to draw amperage through this unit and then try and drive something in a way that where it's been divided down. Doing so would inappropriately ruin the whole effect of the division. You'd wind up not dividing and probably would burn out the resistors inside here. It's meant to provide an almost zero current output that is accurate in voltage. So you have accurately divided the incoming voltage down to within 5 decimal places of the original input. So let's say we put 10 volts on the input of this thing, we could get 0.0001 volt out and it would be accurate. That's the intent. You could then use that as a reference for calibrating your voltmeters or any other device that needs voltage calibration, or a testing source just to test your calibration, and so on. It could be used maybe as a reference voltage for a power supply. That's possible. It with a unit like this, you would like to have on the output, whatever meter load you're going to put on there, you would like to have at least, I would say, a gig ohm. But in the case of my meter that I test with, which is a HP 34401, I get 10 gig ohms. So Using 10 gigohms gives me roughly what, 1,000? Right offhand, I'm thinking it's 1,000 times more resistance on the output than the unit itself has. Don't hold me to that, but it's on that order. So the effect that the meter has on the imbalancing the voltage on the resistor using a parallel effect is minimal, because the effect on the resistance is minimal. Okay, so we've looked at it. We get an idea. It weighs a couple of pounds, mostly because of the cast base. It has some felt feet on the bottom, still there. There's step switches for the first 3 decades, and then a dialing pot at the end. And that's the most critical point, is trying to maintain the visual accuracy of this potentiometer, so that when you're dialing in whatever voltage you want, you have to line up your divisions accurately without having any visible distortion in angle or whatever, just because you're looking at it wrong, or wrong angle. So okay, bear with me. We'll go ahead and do that test, huh? Okay, so we're going to give this DV411 a linearity check. I have at the moment 9.4 in 9999 volts coming in from that Fluke 343A, and I am checking my calibration on this unit with the leading significant digit set to 0. I'm doing this because I know I'm going to get my maximum performance out of this thing error-wise if I eliminate the non-linearities in the first dial, first digit. So I would expect to see all 9s, because I have all 9s coming in. We'll check that. Let's check the voltage coming in. Yeah, okay, see, we have the meter lead coming in on the voltage coming in. We got 9.49 volts. I'm going to move this back to the output. And we're going to go ahead and dial all the way up to the first digit being a 9 again. So this would be our maximum voltage on this unit with all 9s coming in. We've got 3 9s and an 8. So we lost 100 millionth of a volt coming in. Let's just check to make sure we still have all 9s, and we do. Just move the lead to the input. So we've got all 9s coming in. We've got all 9s and an 8. Okay, so that's our first reading, 9.9998. Let's take her down now to 8.999, and we see that we have an 8 at the last digit. Let's go to 7. 7. Okay, we got a 7 and all 9s. 6 and all 9s. 5 and all 9s. 4. We've got 3 9s and an 8. A little bit of a surprise there. 3, we've got 3 and all 9s. 2, we've got 2, 3 9s and an 8. Seems like a little bit sensitive there. Okay, we go to 1. We got 1 and 4 9s, and if we go to 0, we got 4 9s. Okay, going to the second most significant digit, going from 9 to an 8, and we've got 0.8, 3 9s. going to 7, 0.7 3/9, going to 6, it's a 6 right here, I don't know if you can see it, hope you can. We got 0.6 3/9, going to 5, 0.5 3/9, going to 4, 0.4 3/9, going to 3, 0.3 3/9, 2, we got 0.2 3/9, 1, 0.1 3/9, 0, 0.0 3/9. Okay, now we go to our third significant digit on this dial. We see right now we're on a 9, so that's our 9/100ths of a volt. We're going to go to 8. 0.0899 going to 7, 799 going to 6, 699 going to 5, 599 going to 4, 499 going to 3, 399 going to 2, 299 going to 1, 199 going to 0. We got 9.0099. Now we're dealing with only the pot for the last two digits. And I need to stand so that I can get a good look at that pot, and hopefully I can get you positioned in a position where you can see both the meter and the dial. I'm going to try and do that. Okay, I think I can see it now. Going to 0.09. All right, you got 0.0089 going to 8. 0.0079 going to 7. 0.0069 going to 6. 0.0059 going to 5. 0.0049 going to 4. 0.0039 going to 3. 0.0029 going to 2. 0.0019 going to 10. 0.0009, okay? And then finally we should get a 0. 0, okay. Let's run these numbers and see what kind of linearity we get. All right, the results have been entered into the spreadsheet, and we've calculated the error. We went from feeding in 9.9999 volts, and we ran that down until we had 0 actually, but we ran it till we were measuring in the 4th decimal place our whole numbers. So, and in it, over the course of the entire 10 volt range, with 4 decimal places, we got only 4 spots where we had any error at all, and our error measured less than 3.3 thousandths of a percent, and that was at 2.9999, roughly 3 volts. We got a reading of 2.9998 instead of 9, and that gave us our maximum error. But outside of that, to 4 decimal places and 6 significant figures actually, we had 0 readings on everything else in error. Yes, if I had extended another decimal place, you would see error. But that wouldn't be fair to do, since the unit only claims to be able to give 4 decimal places. So it is remarkably linear. This is a graph of the response and the formula. So it's supposed to be within 0.005, so 5 thousandths of a percent in linearity error. I've got a max of 3.3 here. Everything else is perfect. So beautiful. It's a beautiful little instrument, and I think that somebody is likely to be very happy if they're in the market for one of these things. This one's in beautiful shape, been taken care of, cleaned up, painted, all the switch contacts cleaned, and then it's been tested, and you've got a chance now to look at the results. And if you listen to the video test, you can verify those numbers with these percentages here yourself. I will include a copy of this sheet with the unit when I sell it. So, thank you for listening, and see you again next time.